So, and for those of you who have more experience with Java already, you can look here in your project in these extra exercises in packages called gtm.extra01 and forward. You also may look here on online materials of this course here, but for first few extra packages there is no additional information, because for example GTM Extra01 package is still mostly about Java language syntax and algorithmic thinking and implementation of requirements. So you open code, you look on to do keywords. By the way, if you use Eclipse, in Eclipse there is view called tasks. You sort them by packages, and then you can immediately navigate to particular to-do in this to-do list. And then you read these requirements and try to implement them. If requirements seem ambiguous, or if you do not fully understand what your business is, you should assume something and test it out. For example, here one of the first things what you can do is check how these methods are called from JUnit test. And you run JUnit test. You see what is happening here. So first, the most complex number was called, and then iterations was called with number 1, number 2. And so here important part is to know that you can use printing into output for debugging. An important part for such printing out is that all these tests have timeouts. That, for example, if exercise is about networking or database connection, you can't know is something slow or doesn't work, so everything finishes with timeout, and you cannot investigate something for hours. For example, if you want to run something here in debug mode, you first need to add breakpoint, because otherwise running something without breakpoint goes till to the end, and then you can run JUnit test. In debugging mode, you switch to this debugging mode, and then you would like to go it step by step, but what happens actually is that this test is terminated because of timeout. One of improper things you can do is update global settings for test called alltests.java, and here it has floating point number, how much time it should wait for everything, and increase it from 1 to 100. But this is not very proper way to do things, because in many cases when you will work in complicated environment, you will need to deal with external systems, and Accenture specializes in large complicated software development projects. There always will be situations where you will not be able to control some external system, and actually this JUnit test still failed with timeout. This is typical example where you can't just sit hours in the middle of execution of something, because some other system get bored and just interrupts this execution. So important part is for such printing out that for things which happens very quickly, if they happen at all, you can print out something here, and then you can analyze it for as much time as you need. And other thing is that particularly for me, because I'm occasional programmer, not a real programmer, for me, and because I worked as a tester mostly in test automation, not in actual development, for me definitely it's much easier to understand how it works by example, by looking on printed out patterns here on data, than interpreting and compiling and executing everything of Java code inside my head. So don't try to do what computer does well, like compilation and execution. So compilation and execution should be done by computer itself, but do what you know better than computer, for example, finding bugs. And therefore, in many cases, looking on data and wrong data provided by your implementation is easier to understand what is wrong than reading entire code. So, for those of you who have these previous skills of Java development, you go through these extra exercises one by one, look on to-dos, implement, debugging until these JUnit tests passes. For everybody else, we will review Java language itself, our Java language syntax. And talk is about following things. So, about comments, keywords, operators, statements, blocks, identifiers, primitive data types, declaration of initialization of variables, typecasting, scope of variables, conditions and branching, reference variables, arrays, array operations, some Java utility classes code guidelines. This scope of this presentation is quite large, And for some of you who almost have no experience in Java development at all, it may be quite intensive to deal with all these things. Then, if you are confused with so much material, my recommendation is to open Java tutorials from W3 Schools, so www.w3schools.com/Java, where you can go through online Java tutorial with quite detailed description how it works and with online example. For example, first thing is how you can start Java application, how you can print something out. Here is sample code, you can try it by yourself. And here you can write anything you like. And run it. So this is Java virtual machine through the web browser. So if this topic what we will cover currently will be too intensive to you, then you can learn this in your own speed, looking here in these additional materials. So, yesterday I told you about infrastructure, what you need to get your Java code compiling and running. Now more details about this Java code itself. So you write simple plain text documents to do something, and in these text documents you need to deal at least with two different things. First, you need to process some data, and you store these data in variables, and you need to control flow of this processing depending on different kind of conditions. So you do something and you check for conditions. How do you do this? And so main syntax elements of any program are these data what you handle, and this data may be in Java particularly plain data without internal structure. These are called primitive data types, or structured data with more complicated data structure, which are called objects. Then you have different statements which process these data. You can add comments and white spaces to make your code look nicely. An easiest syntax element in any programming language is comments. Comments are ignored by compiler if it's compiled programming language, or interpreter if it's interpreted programming language. And so these are only for humans which are reading this source code. And in Java, standardized way are three different types of comments. One starts with double slash, which means everything after this double slash or two slashes is a comment till to the end of line or line break. Then there are so-called block comment, which starts with slash star and ends with star slash. Particularly in Java, you cannot put comment inside comment. For example, if you put slash star and like slash star star slash here, then this first, okay, show it to you. it will not understand comment inside block comment inside block comment. Something here, and then if you make block comment, so as soon as it gets star slash after slash star, it is considered end of block comment, and everything else here now shows compilation error because it can't be understood as a proper Java code. And then there are documentation comments introduced in Java, which is slash star star, which is used to generate documentation of your code automatically. And for example here, if you look for Java string and you open such website, all this HTML is actually generated using Java.dots tool. The input for this Java.dots tool was Java.dots comment inside Java language itself. And you can create Java.dots documentation for any project. For example, in Eclipse you say export this project as a Java.dots. Let's create here another folder. Let's say Java.dots. And then you have created Java documentation for this particular project. There is index file. So here is list of packages. Here are these classes. And if it would have some comments, for example, where we have some existing classes with comments, not test, for example. Then you see that everything that was commented as a Java documentation comment is put here. And also, this is important not only for Java documentation, but while you are writing code. For example, when you hover your mouse cursor on something, on method, and if you generate Java.dots, actually you can generate it also. You select this method, source, generate. Generate element command. And then when you use somewhere this method, like and you hover it up, you see here this Java.dots comments for one particular element, And if you have some other elements, so this is for method. So for any thing what is considered element in Java, you can see this text coming from Java documentation in your integrated development environment. Particularly for Eclipse, I don't know about other IDEs. There is another unstandardized block command starting with /* and dash, or minus in jargon. And this is unformatted block command. And how does it work? For example, if you have some block command and you want to do some ASCII art or whatever, and you auto format this code, then sooner or later it breaks up these lines. But if you add dash here, then it is not touched by auto formatting, so you can always be sure that your block command will always look the same also after auto formatting. Then Java has many keywords which are reserved for specific needs, and you cannot use keywords to name your variables, to name your methods, etc. And these are about Java structure, about inheritance, for conditions and branching, for exceptions, assertions, and for primitive data types. Particularly in Java, all these reserved keywords are shown in bold magenta, dark magenta color. So this is keyword, this is keyword, this is keyword. So you can't say something like int, because this is reserved keyword. You need to name your variable something else. And theirs is even longer. Then particularly in Java, they decided that keywords const and goto should be reserved. So they are considered as a keyword, so you can't say something like int and call it const, or float and call it goto. But actually, when you use them, you still have compilation error. So you can't use these particular words because goto is considered bad style, especially if you go goto forward, not backward. And for const, Java has a little bit different approach how you create constants. So these are reserved keywords. You cannot use them for something else, but they are also not used, so you get compilation error when you use them. And then you have different kind of operators. What is important about operators is that in general they work with primitive data types. So every time you write operator, like assignment operation or comparison operator, here before that should be primitive type and after that would be primitive type. And also what is important, if you have some experience working with C or C++, in Java operators cannot be overridden. So they work only in one intended way, and you cannot change them. And here is list of these operators. I will not go into much of details of them. We will go through them just one by one for practical exercises. But what may be important here is about logical operators single ampersand and double ampersand and single pipe and double pipe, depending on where these operators are put, they are so-called overloaded. Exact meaning depends on what is in one side or both sides of this operator, but one of confusion may be for beginners. So sometimes when you do comparison, for example, you do if, and you do something like int e, if e smaller than 10, if e plus 1. And you probably need to assign initial value to it. So you do some conditions, and then if you add some other condition, like you can do more conditions, for example, and you may see that there is not much of difference between 2 ampersands and 1 ampersand. It looks like it works the same, but what is not the same is how they work if for these conditions you call some method. And for example, now you see difference how it works. Because if you that condition as a single and or, this means all these conditions are always checked till to the end of this statement. And you see that this is false method was also called and printed something out on string. But if you add double and, it's called, I think, shortcut and, it checks that first part of condition is already false. So all statement together will also be false, and so remaining part of conditions is not checked. So it works faster in such way, but you should remember that if in this condition you call something else which do something, then this call to other method will actually not be happening. And it will not do whatever it does here. And similarly with ORs, we can write it now a little bit differently. Okay, let's still leave this one here, but so only is true is called with double vertical bars or pipes. Is false is not called. Again, because if first part of condition is already true and it's joined with OR, then of course entire condition will be true. And therefore, with this shortcut and this second part is not called. So that may be useful to know. So that's about logical operations. So exclamation mark means not, pipe means or, ampersand means are, and this power symbol means exclusive or, and these are these shortcut ands and ors. This is check for equality, not equality, and other things. So bit shift, not very widely used for Java, because in Java you usually don't do low level operations. For comparison operators, result is always boolean, so this means either true or either false. For operator execution order, this is more or less what you have learned from mathematics in secondary school. And if you are not sure, then of course you can always put normal brackets to force proper order execution. So next thing is statements. And statements are these things where you say for a computer to do something. And here, for example, you add totals from different other variables. And statements are ended with semicolon, and not everything is ended up with semicolon, because not everything is full statement. And typical example here is opening blocks for body of the class. For example, public class test, and body is opened with these brackets. Opening blocks for methods. Opening blocks for statements, for example. Here is condition of statement, and here is statement itself. So now semicolon here. If you add semicolon there and you run it, then you may get surprising results. An example with this one. Why? Because if you properly format this code, it should look like this. If this is true and this is false, and if this is false, so it should not be called, then execute this statement, and this statement is actually do nothing. And then you increment e by 1, which you also can write as a e++. So it is always incremented. Particularly about increments, there are two different ways of increments, pre-increment and post-increment, and we can see difference for it. Okay, let's do it without conditions here. So post increment works in a such way that it returns current result and then increment it by 1. So it prints out initial value of variable and then increment it by 1, and in second line of code we write it out. But pre-increment first increments value by 1 and then returns it. And you see that in some cases, when you print it out later and you already used value of this variable, there is no difference, but sometimes there is difference, and typical example is printing it out or returning, because in one case you return previous value before increment, in other case you return last value after increment. So here return previous value then increment, in this case increment first and then return value. So then blocks are organized with so-called curled brackets or braces, and there are many kind of blocks, and in this small example you see it already. There is one block which is body of our class test, then there is another block which is body of the main method and body of other methods. And if you, for example, use something then you can have blocks for these statements for conditions, and then you can have just unnamed blocks. So this also will compile and will work. Usually you do not use this without actual need, but there may be that sometimes you add some keywords. Don't know exactly, but sometimes you may add some keywords for these blocks, and then you can also use such blocks without some heads for these blocks, like beginning of the class, beginning of the method, or statement, conditions for your statement, etc. So now about data types. There are primitive data in Java and objects, and primitive data can be literals or constants or variables, and objects are more complicated data. These were introduced in Java due to performance reasons. And difference is following, that for primitive data you reserve memory only to store your data, and if you use primitive type like integer, somewhere in Java virtual memory you say use 4 bytes or 32 bits to hold this value, for example int e. So this e will refer to this place inside memory, so you have 32 bits to hold the actual value. If it's like, I do not know, long L, then I think it is 8 bytes, and you just store value. But for objects like string s, it is more complicated, and it always consists of 2 parts, so-called reference part And the reference, I think, is also 4 bytes. And initially, value for this reference is all zeros. And if you want to do something like s length, you will get null pointer exception, because this reference points to nothing, because if you look inside Java Virtual Memory, there is no memory cell with address 0. It always starts with some large positive number, so it refers outside of Java Virtual Memory. And when you do assignment, for example, you say E is 3, you write 3 in decimal here inside this reserved place of memory. If you say L is 7, then you write 7 here. But when you say S is, so you can put, for example, literal value for it. Let's say string. You actually need to create another place in memory to hold this value string, and then this reference refers to this place in memory where this string is located. And if this memory is, let's say, 1, 2, 3, then this value here is 1, 2, 3. Why these complicated objects are done in such way? Because objects may be very complicated. There may be object inside object inside object inside object, and all this data structure, how these are put together, may be very complicated. And therefore, initially, when you declare this variable for object type, you get only a reference part for it, and when you actually initialize it, you create actual, so here is reference and here is value. So value part for it is actually somewhere else. And you can look on it also in runtime. For example, so you can run your application in debug mode and then interrupt its execution at the breakpoint. And for example, here you see that for this variable currently you cannot get any value for it because it is declared but not initialized. You can see only E variable actually with value. But when you assign value to this object, you see its internal structure, and you see here this is this reference part and this is actual value part, where these internal properties of your objects are held or stored. So, and when you declare your variables, you use different kind of identifiers. Naming convention in Java is that you usually start with letter, but syntax allows you to start with underscore and dollar as well, but not with a number. And naming convention usually is that for local variables you start name with lowercase variable. For static variables, I will tell in details later, it is capital letter. So then you can assign literal value into your variables, and literal value means you write value literally. All these are literal values for these variables because I wrote these values literally inside my code. But if I do something like so here I will change value of this primitive data type integer e 5 times, I think. Now this value, what I will get, will be calculated. It is not literal value because I assigned literal value here to 0. But then this value is calculated, so prepared dynamically. Similarly for this complicated type or string, and also what is important here is that you see that for primitive types, these are considered also keywords. They show up as a dark bold magenta in Eclipse, but objects first name starts with capital letter, not with lowercase letter, and are shown as a normal text, not as a bold magenta, but just black text. And again here I can assign literal value to it, but here I can calculate its value. For example, another literal value. Okay, and just for fun we can do it 5 times in a row. And you can also see here that so-called local variable, because this and that is different variable, but their scope of living is for these iterations here, and then new variable is created, located completely different place, but only the same name is used for different local variable. So this name is the same, but variable is different, and so here what I'm doing is adding value to this string dynamically. I still use some literal part here when I write literal value, but I'm also calculating its value by some algorithms. So for constants, in Java you use final keyword. So why it's final, not const, we will go in details later, because for primitive types you can use final as a mark for constant value. For example, if I say that my integer e is final, then I get a compilation error here when I try to change it. So for primitive types, final keyword is the same as constant, but for non-primitive type, precise meaning means that final is you cannot reassign it, but there are some complicated data types like arrays. For example, where my Eclipse went. What did I press there? Ah. So for array, array is also object, and you show that something is array using these square brackets, and in this case I have array which contains primitive integers inside it. And with final keyword, what I cannot do, I cannot say, for example, integers is new integer with different size. That is compilation error, and that is what precise meaning for final is. You cannot assign it more than once, but internal structure still may be changed, because I can say is for cell 0 is 0 and is for cell 1 is 1. So internal structure of my complicated object still may be changing, but only initialization cannot be executed again. And if we run it in debug mode, so here is this primitive data type which only have place to store value, but for array we have 3 cells to hold these primitive types, and I cannot reinitialize it. For example, reinitialize it to different size, but I still can change it internal properties. For example, I can write different values inside cells of this array. So where is difference? So my primitive integer I is just 4 bytes of value, but my integer is first is just reference. If I write following, it is just reference, and reference initially is all zeros or null pointer or null reference. So I can rewrite it in following way. So here I have declaration, or this part, together with initial assignment. But here I have declaration as separate part and initialization as separate part. So here also I could write it in more verbose way. Let's change it to something more interesting to see difference. So, and when I say e is 1, I write this value directly here, but for arrays of integers I need to say is new, and new is important keyword for objects, and in this case I say, for example, new integer with 3 cells. What is actually happening here is that I need to hold values for 3 integers. So value for integer 1, value for integer 2, value for integer 3 ints. And how can I organize it? I organize them in the following way: that array has metadata about them. Where it says it will hold integers, and number of integers will be 3. And then this reference points to these data structures, which says that here you can read 3 integers in a row. Jump by 4 bytes, you will read value for 0th cell of this array. Jump by 4 more bytes, you will read value. So 0th cell, 1st cell and 2nd cell. Or if you can, because you know how long integer is, you can immediately jump to cell 27,000 or whatever. So, and this is length. Type and length of this array. And that's how approximately array looks inside virtual memory. In debugger mode you do not see separation between reference part and actual data part, but you see here that integers, this array have 3 integers inside it with index 0, 0th cell, 1st cell and 2nd cell. And then particularly for string, this is also object. It doesn't stop in this breakpoint. So you see internal structure of strings, and strings in terms of stored data are also arrays, and strings are arrays of bytes. For example, when I say string s, I first create this reference which points to 0 and get null pointer reference, and when I say s is string s as a literal value, I create array of bytes, So that means I create object which says I'm array object. I will hold bytes. Number of bytes in this case I think is 2, because one single character in Java takes 2 bytes. Or maybe 1, depending on how modern Java you are using. And then actual value to hold this value. So and then this reference points to here, and actually to be completely correct here, we have say that it is string. So where is the difference between array of bytes or array of characters and string? The reference is here declaration of what it is, because when you create array, with array you can do only following things. You can initialize it and then you can refer to specific cell to this array and assign variable, and that's it. But even though inside string there is array, it has much more, because for string you have a bunch of many methods here, how you can do different kind of string operations with these arrays of bytes. So what does it mean? It means that here inside virtual memory, in this heap part, there is also definition of all classes loaded, and somewhere here definition of array class is loaded, somewhere here definition of string class is loaded. And when you declare just simple array, only thing you understand about array comes from definition of this class, and this means you can refer to particular cell inside this array and write some values here. And that's it. But when your object says I'm actually object of the string class, it refers to the definition of the string class, and for string class you have very many methods for string operations. That's what's important about strings versus arrays. So I think I told. So now about char. Char is one of primitive data types which is used to write characters in Java. And char contains 2 bytes or 16 bits. And that means it can store values approximately 65 or 2 in power of 16 different values. And what is very important to remember is that not every character you see on screen is one single character inside Java programming language. For example, you open character map and you'll see here one single character, so you cannot select part of it. But when you look how it is actually stored, depending on encoding system it is using, it contains either 2 or 3 bytes in total. And particularly if you store in Java, I think that in older Javas it will take 2 Java characters or 4 bytes, and maybe in more modern Java, because Java is gradually going away from idea that characters are stored as strings are stored not as arrays of characters but arrays of bytes, because UTF-8 encoding system is the leading standard. And what you need to know about UTF-8 encoding standard for non-Latin characters is that Latin characters takes 1 byte in length to store data. Non-Latin Latin characters with diacritic marks mostly takes 2 bytes to store. Japanese characters takes approximately 3 bytes to store, and Chinese characters may take 3 to 4 characters to store. So what you see inside internal memory, how many bytes it will take, is actually more bytes than you see characters on a screen. And that is quite important to remember. So here is range and size of primitive types in Java. In standard Java, there is no unsigned numbers. In more modern Javas, there are unsigned numbers are only positive, but still not very widely used. So this means for particular byte you can store value from -128 to 127, not from 0 to 255 as for C. And Boolean takes approximately 1 byte in memory because of addressing issues. So inside virtual memory, everything is managed automatically. And if you create, for example, in your code, your Boolean B, you need to put it somewhere in virtual memory, and in theory you need to hold only single bit, either 1 or 0, to store it. But problem is addressing. In Java virtual memory you cannot address less virtual memory than single byte. So this means just to store 1 single bit you will use 1 byte or 8 bits. And so this means only last bit will actually be used to store this value. And if you will another Boolean B1, it will be put somewhere else. So in total you will have large memory overconsumption. How can you deal with this? In theory, Java compilers might see that if you have long list of these booleans, and it may compress it, but it is not guaranteed. In practice, what you need to see is an object called bitset. And then bitset is array of bits. Something like this. I cannot use bitset. You do not assign, you just say. And then what you have created in such way, you created array of the bits where you have two styles of addressing. For this bit set object, of course it's object, you create reference for it, and when you declare it, when you initialize it, you say that it will have, how many I said, 10 cells, it is length, and then and here it says, of course, it is object of bit set class, and here it has reserved 10 bits inside memory. And when I refer to this object, of course I refer with precision plus minus 1 byte where it begins, but then I can use this index to refer to particular bit after bit immediately. So for bit set object I can use and refer to only one single bit inside virtual memory using this index operation. So that's what you need to know about size of primitive types and other. So default values are all zeros for initial values. For boolean that means false, and for object reference it means null. A little bit comments about default values. You may say something like int e and then int e, and you will get immediately compilation error here, because compiler says that you cannot compile it because variable is not initialized. But here again we need to remember about objects inside objects. And here we need to talk about life cycle of variables. There are local variables which live inside block of code, where block of code is either after conditions or inside method or whatever. These local variables live only as long as this particular part of block is executed. Actually, we can so these are local variables, and these are and in IDE you see that these are shown differently. These are shown blue and these are shown, let's say, brown. And for local variables you cannot use them without assignment, because checking is this assignment or not is very simple and easy task for compiler. So this always should be initialized, like initial value for this. But if you declare variables outside any other method inside body of the class, then these variables are used as a template of an object. And here we need to talk about our customized objects. And I have created my own custom object, and this is internal structure of my custom object. And we can create such new object. and then print them out. Let's say print out everything. Yes. And you see that default value is 0, false or null for object. And now, if I will try to do something with this string which is not initialized, I will get null pointer exception because length method cannot be invoked to an initialized object. And why it's uninitialized? Because there may be objects inside objects inside objects. Because here I can say something like that there is another test object inside that one, and then I can go, compiler needs to go in structure of structure. And what means object inside object inside object? It actually means object refers to object refers to object. Example, you can create one object. Let's say this is our test object. And then it has references to other objects, let's say string, or maybe another test object. Another test object and then to string. So object inside object is just a business term or allegory. What actually happens is object refers to object which refers to object which refers to object. And if you go in details, of course, there is this reference part of object, and then there is value part of object, which says that in this case type of object is test, and somewhere in heap part of memory there is test class definition, and from class definition it knows that 4 bytes here for integer e is value for integer, then 1 byte is value for boolean, and then there should be reference to another object. So what I have created, and I will show it in runtime here. So what is missing here in runtime is that each object consists of 2 parts, a reference and actual value. So here it shows only values here, but so it's more simplified. But what actually is happening is that when I have created my test object here, I created this reference part, and when I initialized it, that reference part referred to actual data. So what you see here actually should be something like this. When I say test, 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 I create the reference for it, which points to null. And when I say test is new test, I construct it. Then I have to look on definition of the test class, and I see that I need to construct one integer, one boolean, and one string. So I create for primitive types, it's simple, 4 bytes for integer, 1 byte for boolean, and reference for string. And here I need to remember that it is test object, and I think that's it. So now I can immediately read values for integer and boolean, because their default value will be 0, which means actual value will be 0 for integers, and zeros will be interpreted as a false for booleans. But if I will do something with this string inside my test object, it is still another object and we have created only reference for it. And therefore I need to initialize this string like test s is s, for example, to actual value. So again I need to create object of the string class, which says I'm string object. And string contains another object inside it, because it contains array, so it contains array inside it, and length for this array, let's say, is 1, and value for it is s. So my object reference refers to actual data here, and for string it refers to actual data here. And if it would be more complicated data structure, it would refer to other place, etc. And because of this reference to reference to reference, which may be very hard to analyze, default values for these object templates are not checked during compilation time. So you can just create your object, and if you will not initialize, for example, objects inside it, like strings, then you will get this no pointer exception. So I hope I told you about declaration and initialization. So Java is strongly typed language, and therefore you need to cast values if you need to assign different types. We will look in details for practical exercise. So I started to talk about local variables and member or instance variables, which you also can call as a templates for an object, and now about static variables. So third type of variables is in Java are called static variables. And here I'm using this naming convention that static variables are named starting with capital letter, not lowercase letter. Where is the difference between this and that? Group of these variables is used as a template for any newly created object. But these structures are, we can say that they belong to the class. If we look in more details inside virtual memory, so here we have definition of our test class, we have these member variables, which is int e, boolean b, and string s. And then we have this class or static, capital E, static, boolean b, string s. And when we create a new object like test1, then we create reference, and then this is taken as a template to create data structure for test1. Data, or let's say value. And then I create test2. Again, I have reference part for it and value part. And this will be taken as a template, but actual values will be different. So placeholders for all these objects will be different. So this means I can create similar but completely different object out of this template. But when I refer to these static structures, I always refer to class itself. So these are common data structures. And to refer to them, for example, here we can say t1 in x1. And when we run it, we see, for example, data structures for T1 test object. And this static integer e, which belongs to the class, is currently 0. We can assign value to 1 for it, and such common data structures or static data structures are used as a total counters, etc. So here I'm using this integer e as a counter of newly created objects. And then I can create another test object which has its own internal properties, and I can increase this total counter to 2. And then I create another separate object, and I can increase total counter to 3. So for local variables, I refer to them by using this created object, this variable, which refers to this created object. But for static structures, I refer to them using name of the class. So if I go to the definition of the class, F3 in Eclipse, Control Shift B or something like this in IntelliJ IDEA, then I see that I'm going to the class. So these are these 3 types of variables in Java. Local variables, which live only inside particular block of code, in this case inside body of the main method. Internal data structure or template for an object inside body of the class, but outside any other method, which will be used as a template for these objects. And static structures, which are used as a common counters and other shared data structures, and we can say that they belong to the class. Any questions, comments so far? So here is different representation of the static keyword. For example, for total counter of these, you can also use static methods to deal with static structures. Typical static method is public static void main method. Now about types of methods also a little bit. So instead of writing test t++ here, I could add static So this is formal reference to static data structures, class, dot, and name of variable. But you can write it also shorter inside a particular class. You just refer to this variable. And you see that static data structures are shown in italic. So templates for an object, blue, but normal. Static structures, blue, italic. Local variables, brown in Eclipse. And then you can use, for example, this method to increment total count of our objects. And you see that static methods are also shown here in italic. And here we can use for example, to do this in following way, we can use command method. And where is difference? To call this particular method setI, you always have to have reference to the current object of this class, because this method cannot be called without having reference to an object. So ceremonial writing would be following. For static methods, you refer to the class and then to static method. But for these local member methods, you have reference to the object and then call method for this. So that's also about static and non-static methods. So about control flow statements, I hope there is not much to discuss. You have Boolean expression statement of block. If you need to write many statements, you use curly brackets after this expression. If you need to check for particular several conditions, you can use switch instead of many ifs and else ifs. In Java, starting with quite old Java 7, you can also compare for strings. So this is C-like for iterations, but what is recommended in Java to use iterations, if you can use them. Then you have different kind of cycles. While cycle, when you first check condition, then do operation, do cycle where you first do and then check it. So this may be not executed at all. This do will always be executed at least once, because you do first and check conditions later. When you go out of loops, you use break to break out of loop completely, or continue to break out of current iteration but still continue loop. So then about reference variables, I think I told more or less about them already. Particularly for string, you can use very verbose variant to write strings and create them similarly to other object. You say string user is new string and pass some literal value to it. But this assignment operator is overridden already in Java. As I told you, you cannot override operators by yourself. But in Java, assignment operator is overridden, particularly for strings, because this verbose variant, how you create new strings, can be also rewritten in much shorter way. String user is an actual literal value, because this assignment operator for string is overridden in such ways that it is the same as construction of this object with passed parameter here. So I think I told most important things about arrays, and here is a little bit different but the same representation what I told you. You can also initialize array immediately after each declaration. Then you say string or whatever array is, and then opening curly brackets and comma delimited values for it. We will not cover much of multidimensional arrays, but you should know here. So arrays cannot be resized because internal structure of arrays is immutable. So if you if you need bigger array, you always need to reinitialize it completely. So this means you will create completely new data structure for this array. So in terms of virtual memory, it looks something like this. You have your array, let's say int e, and when you say e is new int of 5, you created this reference here of e, and new int 5 will be 1, 2, 3, 4, 5. 5 integers, length is 5, it is array. Something like this in data structure. And when you will say e is new int 10, you will create in some different place cells to hold 10 integers, length will be 10, and it will be array of integers. And in first place, this reference will point to actual values somewhere here, and then you will delete that and will say that reference points to somewhere here where actual data is. But you can copy arrays if you need, for example, and then about string. Okay, finally, some fun about strings and string builder and string buffer. Some of you may know this already, some may not know, but string is an array of bytes. In old school Java it was array of characters, but newer Java reorganized the implementation and this array of bytes. But string is immutable object, and for example, if you need to change your string and, for example, add something at the end of the string, you need to do something like this. You reinitialize the string all the time to modify it. And in this case, we just add more characters at the end of current string, and when we run it, we wait for some time, and it completed. And what is happening inside virtual memory is that when we create string to hold just letter A, we need to create byte of array of bytes to hold value for A. For example, it is 1 byte in length, so it is array of bytes, and our string says it is a string which contains array of bytes, and our reference is here. And when we need to add A and A, we need to create completely new structure to hold A and A, and our reference points to something else. And when we create A, again we need to create resize bigger array of these bytes. So length was 1, 2, 3 here, still array of bytes, and it is inside string, And when these becomes larger and larger, most of operations comes just to copy all this previous value to the next one, and because of that it becomes very slow when you need to deal with large amount of data. And therefore strings shouldn't be used when you do such kind of changes of strings, like changing it to uppercase, change it to lowercase or whatever, because it will be very inefficient. And you see it's still working and has not finished yet. And therefore, instead of string, you can use completely different object called string buffer. Okay, I tired to wait for it to finish. So string builder is organized in different way. String builder is scratchpad for data. You create, I think, 2 or 4 kilobytes of scratchpad, and of course you have this reference of this, and then when you write something here, blah 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 blah, you just write here into scratchpad. If you need to add something after current thing, your cursor or writer moves forward. If you need to add something before that, it just goes backward. So it is something like infinite loop of writing. Start from here, and when it's full, what it happens is it creates another buffer as a link to it, which is twice as long, either 4 or 8 kilobytes. So you write here, then you write here, And when it's not enough, you add another reference to next buffer, which is twice as large again. And so twice. And when you try to do this, you see that it works much faster. And when you increase amount of operations, it still works pretty fast. Only you got out of Java heap space. What means Java heap space? You put objects and other things, complicated things in heap, because you always add next size of this string builder twice as big as previous, so this scratchpad of this buffering to read grows exponentially, so sooner or later you just run out of virtual memory which was reserved for this virtual machine. And that's what you need to remember when you do large operations with data, for example strings or whatever, that if you are reassigning value to the string and this string is very large, these operations are very slow. So where is the difference? String is very efficient when you just need to hold data, because it has reserved only as much data you need to hold actual value. But when you need to do many operations, it works very inefficiently, because you always need to reassign and create new data structures for all changed data. So good for storing data, not good for changing data. For string builder, it is not efficient for holding data, because even though you have it empty, you have 2 or 4 kilobytes already reserved as a scratchpad, but then internal operations goes very fast. So complete opposite of strings. And I think that should be enough as an introduction about little bit advanced concept of Java syntax. Do you have any questions or comments?